Good morning, everyone. So the title of my talk is a neural framework for tracking and detecting events in Twitter. And then my name is Yongli Zhang. I'm a PhD student from University of Houston. And here's an outline of my talk. So I will first give some introduction about this project and the two-stage system we propose, and some experimental result we got, and relative future work, and conclude my talk. First, starting with the motivation. So everyone is using Twitter, so therefore there's unprecedentedly valuable knowledge behind this. So if we can mine the Twitter data, so everyone is interested to know what is happening now, and therefore we can get some actionable knowledge. And for example, the company might use Twitter to recommend products, and the government can do some political analysis or do some disaster management. And then the research focus of this project is to develop an efficient framework for detecting and tracking events in Twitter. And in our project, we integrate the natural language processing techniques and machine learning techniques. Specifically, we integrate the LDA-based topic discovery approach and the density control-based spatial-temporal clustering approach. The spatial-temporal clustering approach is an extended approach called ST-COPA. That's a previous algorithm we propose. And this approach is very time efficient. It can process large data stream in approximately linear time. And next is the two-stage system we propose. And on the left side is a detailed diagram of the system. On the right side is kind of a simplified version of the system. First, we get all the geotag tweets as our input. We divide them into temporal batches. And then we apply the LD-based topic modeling. And after that, we get, for each geotag tweet, we have an event label. And after that, we apply the density estimation to all the locations of the event. And we apply the density estimation, the contouring algorithm, and the post-processing. Then we get the spatial clusters for each batch. And after that, we need to, anyway, the final goal is to establish the temporal relationship between the batches. So after we get the spatial cluster for each batch, we apply the KL divergence and some distance functions we propose to establish the continuity between the spatial clusters in consecutive batches. And starting with the inputs and outputs, the input is very simple, just all the geotag tweets and the data collection area. The output is just a graph of related spatial clusters. And here, in particular, the relationship is the continuing relationship between the clusters. And here's a summarized description of the system. So in stage one, we do LDA-based topic extraction, and there are 3 steps. First is pre-processing, and for pre-processing, just some text pre-processing. Then after that, we apply the LDA, the latent derivative allocation, to get the topics. And after that, we do the topic assignment. We need to assign the topic label to each tweet. And after that, for stage 2, we just apply the density estimation, contouring algorithm, post-processing to get the spatial clusters first. And after that, we get the second step is to get the spatial temporal clusters. And in stage 2, it supports both the relative and the absolute density. And I will cover all those steps in more details in the following slides. First, starting with the LDA-based, starting with the latent derivative allocation. Some of you might not be very familiar with this approach. So in a nutshell, this approach it just returns a a list of topics, and for each topic, it's just a weighted list of words. So that's just keep in mind, it's just a list of words it returns. And after we apply the LDA, we get a list of topics and how to assign the topic label to it. We just summarize, because the LDA returns a weighted list, right? Weighted list of words. So for each word, it has a weight. It has a weight. So we just sum up all the weights of the topic words that occur in a tweet. Then assign the topic with the highest sum. And in some cases, we might assign no label. We just set a threshold. In some cases, we might decide there's no dominating topic for this Twitter, right? We just consider it as an outlier event, outlier topic. And after that, so the key point, as our approach is a density control based approach, so the key component is the density estimation. And in our case, we use the kernel density estimation, and our current implementation uses the Gaussian kernel. And we just apply this to the locations of the event, just 2D locations. And that's the absolute density. Like I said before, we also support the relative density. The relative density is just the case divided by the control case. And in this application, the case is what is the location of the event. The control case is what is all the geotag tweets we collected among the data collection area. So therefore right now we have two densities, right? One is the absolute density, the other is the relative density. After we get these two densities, we apply the contouring algorithm and some post-processing to get the spatial cluster. The spatial cluster are just the polygons, right? Just polygons. In order to see the density variation among each cluster, we use multiple thresholds for the contouring algorithm. So that's the kind of the spatial cluster model we have. We define a data structure called the contour polygon tree, and so this is an example of two spatial clusters with three thresholds. Yeah. And after we get the spatial clusters for each batch, the next step is to establish the relationship. Especially in our case, it's a continuing relationship between these spatial clusters for consecutive batches. And to do that, because for each batch we have one thing we have is the topic list, right? The other thing we have is those spatial clusters, those multi-layered polygon models. And to establish the continuity, for the topics we just use the KL divergence to calculate the distances between the topics. And if the distance is low enough, we consider as a continuing topic. And to establish the continuity between those spatial clusters, between those multi-layered polygons, we propose like several distance functions. And a simplified description is we just calculate the kind of the overlap of those spatial clusters, because for those spatial clusters we know their locations, right? So we just calculate kind of the overlap divided by the union, something like that, to see how much, what's the percentage of overlapping. If the overlapping is high enough, we consider it as a continuing spatial clusters. So next is so that's the whole 2-3 system. After the, so I'm going to give you some experimental results we have. Here we use two events to demonstrate our approaches. First event is a Buffalo snowstorm event. This one is kind of the most serious snowstorm event that ever happened in the U.S. history, I think. And case 2 is the Ferguson Riots event. And so first, on top of the table shows you the snowstorm related topics we have for 3 consecutive days. So here we use the daily batches. And as you see, the KR divergence between November 17 to November 18 is 0.64, and between November 18 to November 19 is 0.45. So as you see, both values are very low, so we consider this as a continuing topic. And based on the words, you can see on November 17, people start tweeting about the snow, but there's no serious problem. It's only about the snow, And on November 18 and November 19th, as people start tweeting about the effect of the snow, the traffic, the school, the home, the house, right? And next, this is for the kind of the result of stage 2. We have on top is the result of the relative density. As you see, the Buffalo City is the only cluster we get from for the relative density. That's the only cluster we have, the Buffalo City. On the bottom is the absolute density. As you see, not only the Buffalo City, but also the New York City. There's a lot of people tweeting about the snow, right? But that's the difference. But for the relative density, there's no cluster at the New York City. Yeah, so the relative density is kind of means that there's a high percentage of people tweeting about this event. Yeah. And then we focus on the Buffalo City only, and those are the clustering results we have. On top is the relative density, and on bottom is the absolute density. On top, as you see, based on the relative density, there's no clusters at the downtown Buffalo. But for the absolute density, definitely there, because as you know, the downtown is almost like a populated area. There's high population, so high density of population. So therefore, for the absolute density, there's a region at the downtown Buffalo, and also there are West Seneca, and that's also cluster. There's a continuing cluster at the west of West Seneca. Yeah. But for the relative density, there's no continuing cluster. We identify no continuing cluster. The second case study is the Ferguson Riot event. And based on the words, as you can see that people start tweeting about the event on November 24th. And after that, on November 25th and 26th, people start tweeting about how the government handles the event, like National Guard, police, etc. So the LD can the LD give you a list of words. So based on the words, you can see how the topic changes over time. This is for the absolute density. We can, for the whole Missouri state, we can identify a continuing cluster at St. Louis. Actually, for the relative density, we get the similar result, almost the same result for the relative density. And then we focus on the St. Louis only. And as you see, there's a continuing cluster between November 24th and 25th. And the cluster grows larger. Also, the density goes higher. As you see on November 26th, there's a red polygon. The red polygon means the density is higher. But on the other 2 days, there's no red polygons, right? And here's some related work about this research. Like latent dirichlet allocation, there are a lot of people using them for the Twitter-related research. And for the Twitter event detection approaches, there are some approaches they use hashtags only. Some projects use popular supervised machine learning algorithms like naive Bayes or support vector machines. Also, some projects detect abnormal spatial, temporal, or semantic tweet frequencies and patterns in real time. And even though there are some density-based approach for event detection, but none of them are serial approach. Our approach is a serial approach. It uses time and space in parallel. And compared to the parallel approach, the serial approach is it's more efficient in terms of time and space efficiency, right? Complexity, right? Also, the clustering results are easier to interpret, and there are also a lot of they are designed for specific application, but our system is kind of more general. You can apply to any events, right? And it also supports the absolute density and the relative density. And for future work, we just we need a more thorough experimental result evaluation. And part of the research is reuse in emotion mapping and emotion change analysis across the United States. And it's going to be presented in the following presentation. And for conclusion, so we propose a novel serial and spatial-temporal system for detecting and tracking events. And the system summarizes events using a list of words and using polygon models to describe the regions of the event. And we apply contouring algorithm to get clusters, spatial clusters as polygons, and it uses aggregated distance functions to establish continuity. And more, as far as we know, this is the first approach to use both relative density and absolute density to the event detection in Twitter. And however, according to our experience, the LD doesn't always work as described. And I think that's all I have. Yeah. Questions?
So you mentioned topic continuity. Is this topic continuing from one tweet to another tweet, like in a sequence? Like my question, maybe it's related with what you said about topic continuity, but I'm not sure. Like sometimes people tweet and they continue, we put in like plus sign, so meaning that it's continuing, or like Twitter floods, right? So the topic will be on the first tweet, but the remaining like next 5, 6, 10 tweets will not have one of those keywords that looking for to identify the topic. Do you handle that in this work, or is it just it looks every tweet individually?
It's just the sequence. We do not consider the gap. It's just for consecutive temporal batches, if it's continuing or not. We do not. If there is a gap, it disappears. Then it continues again. We do not consider this case. Yeah.
But if they come right after each other with a, let's say, special like plus sign or dot sign or something, I mean, this is an extra information you can use to identify all these are same topic. Do you use that, or you just treat all the tweets separate, like unique tweet, one tweet?
We just like we have two lists of topics. We get the distance, the KR divergence after we apply them. We get the distance matrices. We just pick the lowest one, you know.
Okay.
Kind of, yeah.
Okay. Does your Twitter analysis take in the role of influencers, like, you know, that have more followers or reputational rank?
No, we don't. We only use the locations, like, yeah. We do not consider that.
Thank you for a very nice talk. This is Umayya Abbas from Baylor. What API are you using, and what proportion of tweets are you able to geocode?
I'm not using any API. There's a public accessible data set. I think it's for second half year of 2014. It has all the geotag tweets for across the United States. Yeah, and it's just all the tweets with the geotag. Yeah.
Okay, but if you're implementing this in the real world, you would need to collect the tweets somehow, and then geocode them, right?
Okay, I see what you mean. But okay, I see what you mean. Actually, right now we kind of use the geotag tweets as a sample. You know, we're not using any geocoding thing. Like if they do not enable the geotag, then we do not use this tweet.
How many tweets did you use in your analysis for the Buffalo? Because we just heard a previous speaker say less than 1% of the tweets that you occurred. What is the number of tweets you do in this analysis?
I think for one day for the buffalo, it's going to be 10,000 around.
And Ferguson?
For the Buffalo City, it's around 10,000, I guess.
And
I forgot the
Ferguson?
exact numbers.
And for the next analysis on Ferguson, what was the?
It should be similar scale, yeah.
Sorry. Well, thank you very much.